x cubed, shit, right? We're going to have to do long division, aren't we? Right? We're going to have to do long division because the power on top is bigger than the power on the bottom. Crap, right? So let's do our long division. I'll do it here. So long division first. Inside my division box, x to the fourth, 0x cubed. Careful there, because you don't have an x cubed there. Minus 2x squared plus 4x plus 1. But I don't need any more zero spacers in there because I'm only missing one term. On the outside, you put the divisor, the denominator. When you put these in long division, you always make sure everything is in descending order. Highest power of x down. All right, to turn x cubed into x to the fourth, I need to multiply by x. And then multiply x through to each one of these terms. 4 multiplications there. And put them underneath here. So I should get x times x cubed is x to the fourth, put it right there. X times negative x squared is negative x cubed, put it right there. X times negative x is negative x squared, put it right there. X times 1 is x, put it underneath the 4. X. Come through, subtract. Subtraction changes the signs. Minus, plus, plus, minus. The x to the fourth goes away. I have an x cubed. I have a minus x squared, a plus 3x, and a plus 1. Are you all in agreement so far? Can I keep going? By 1, right? I can turn x cubed into x cubed by multiplying by 1. So I'll put plus 1 up here. And now I just multiply that by 1, which should be nice because that's just that, everything I see there. X cubed minus x squared minus x plus 1. Change the signs. Minus, plus, plus, minus. What am I left with there?
4x plus 2.
4x plus 2, everyone see that? 4x plus 2. The x cubes are gone, the x squareds are gone, right? 4x plus 2?
No, it's 4. Yeah, it's just 4.
Oh, this is a minus.
Sorry, was not looking at
That's right. I'm not paying attention half the time I'm up here anyway, so. 4x, yes? So we're good with that? That's our remainder, right? Because we can't turn x cubed into x to the fourth, right? The power here is lower than the power there. So that's our remainder. So we put plus the remainder over the divisor, right? All that crap right there, x cubed minus x squared minus x plus 1. That's my new integral. My new integral is the integral x plus 1 plus 4x over x cubed minus x squared minus x plus 1, all of that dx. So does it look nicer now? Maybe a little bit nicer that we've done long division, right? A little bit? We can do the first two terms, can't we? Yep. So if I go right now, I can actually turn this into 1/2 x squared plus x, do the antiderivative of this, antiderivative of this, and then I'm still left with trying to figure out the antiderivative of this, right? And now that we've gotten to this point, I'm going to do partial fractions, but I need to factor the denominator, if possible. So what? You could pull the 4 out up top. Totally up to you. Do you all want me to do that?
Sure.
Yeah? You want me to put a 4 here? Fine by me? All right, I'm going to see if I can factor the bottom real quick. I'm going to do it over here. if we're going to factor x cubed minus x squared minus x plus 1, what factoring technique do we use when we see 4 terms? What do we try? No? Can't pull an x. They don't all have x's. 4 terms. Grouping. You slash it right after the second term. You look, what can you pull out of the first 2 terms? X squared. What's left when you pull x? X minus 1. Now what you need is to factor something out over there where you're also going to have an x minus 1. So you pull out a negative 1. X minus 1. Now that these 2 things match, your next line is x minus 1 times x squared minus 1. It's whatever these have in common, you're pulling that out, and then whatever coefficient is here and here goes in the next parenthesis. And that's it. You recognize this? X squared minus 1. Difference of squares. What's the difference of squares? So this actually goes a little further, doesn't it? It's x minus 1 times x plus 1 times x minus 1. Right? X minus 1, difference of squares. X plus 1 times x minus 1. Yeah? Isn't this the same factor? So it's a repeated factor. So let me come over here now. This is what we have. We have the x plus 1 on the bottom, and we have that repeated linear factor, x minus 1 squared. That's me putting this x minus 1 together. That's my new denominator. You can see why Cal 2 students love partial fractions in the partial fraction section so much, right? Sorry I erased that so quick. Are y'all with me? I need to do partial fractions on that. So time out over there. We can come over here. I have x over x plus 1 times x minus 1, that quantity squared. I know because these are distinct linear factors, I need a over this, and that one's squared, right? So I'm going to need b over that, and then b over that squared. So a over x plus 1 plus b over x minus 1 plus c over x minus 1, that quantity squared. And now I'm off to the races trying to get this. Yes?
If we would have left it like x plus 1 and then x minus 1, another x minus 1, and then we did the partial fraction, would that be wrong or what would happen?
Hold on.
You know what I mean?
I know exactly what you mean. You were asking if I just did x plus 1, x minus 1, x minus 1, and did a over x plus 1, b over x minus 1, c over x minus 1, would it work? I think you're going to have an issue with that. I think you'll run into a problem. Yeah, because I think if you work it out, what it's going to do is eventually you're going to get back to this expression. I'd have to work it out, but I think you won't be able to get one of the variables. All right? Fun time. Now what? What do we do? Clear the fraction, right? Clear the fraction. So I'm going to multiply both sides by x plus 1 times x minus 1 squared. I do that here. I do that here. X plus 1 times x minus 1 squared. On the left side, I get x. On the right side, here to here, the x plus 1s cancel, right? And you're left with the a and still the x minus 1 squared. Here, when I go here to here, the x plus 1 doesn't cancel. One of the x minus 1s cancels, but only one. So I have the b here. I have the x plus 1. I have one of those factors still there. And then finally, on the third multiplication through, I have c. The x minus 1 squareds cancel, so I still have x plus 1. Okay? Now I can start thinking about doing the short way right now if I want, okay? You can start plugging in values. You're going to run into a little bit of an issue though, because it's hard to get b from here. Because to get b, how would you get b? You would have to kill this off, right? Which means x would have to be 1. But that'll kill this off, you see? If I let x be 1, it's going to kill this as well. There's no way to get b without, you can't kill off a without killing off b. You can't kill off c without killing off b. Now you can still do it, certain things work out, but look, it's not, to me, okay, it's not that hard to expand that out. We've done x minus 1 squared 100 million times. So I'm going to do that in my head, and then I'm going to distribute an a through it. So I get ax squared minus 2ax plus a. So all I did was, this turns into x squared minus 2x plus 1 when I FOIL it, and then I passed an a through it. Agreed?
Yeah.
This one, when I multiply those two together, what do I get? X squared minus 1. And then I pass a b through it. So this is bx squared minus b. And then on the last one, just pass your c through, and you get cx plus c. I know I went kind of fast through that. I'm trusting you could expand that out. All right. Now what I have is x equals, let's collect my x squareds together. I have this one and that one, right? So I have ax squared plus bx squared. So I'm going to write that as a plus b x squared. Then I have my x's. There's an x term. There's an x term, right? This is negative 2a. Be real careful here. This is negative 2ax. This is plus cx. So watch what I do here. This will mess students up. I'm pulling the x out of both of those. I have negative 2a and I have plus c.
Minus b?
Where? What? Minus b?
Oh, wait, I'm sorry. No. Not looking
We're
at
good?
it there. Yeah.
Okay. You all right? And then finally, anything that doesn't have an x. So I have an a minus b, and a plus c. So that means I have plus a minus b plus c. I'm going to put it in parentheses. You don't need it, but I'm just going to put it in parentheses. That's kind of to show you that that's the number by itself. Yeah? This is the number in front of x squared. What does that have to be? 0, because there are no x squareds over here. Or you could imagine there's a 0x squared right there. Okay? So you know that a plus b has to be 0. All right? This right here has to be what? 1, the number in front of x there. So negative 2a plus c has to be 1. And then what does this have to be? This is the number by itself. And there is no number by itself here, so that has to be 0. A minus b plus c must be 0. And then, yes, question?
Okay, so to find the missing terms for the x squared on the left-hand side, there's nothing 0 plus x plus c.
Yeah, if you want to look at it like that, that's what the left-hand side is. And then you go to your calculator, right? If I did RREF on this, bracket, bracket, I would do my first equation is 1, 1, 0, 0. My next equation is negative 2, 0, 1, 1. My next one is 1, negative 1, 1, 0. Right? 1 in front of that, 1 in front of that, there's no c's, so 0 and then 0. Negative 2, there's no b's, so 0 and then 1 in front of c and then 1. And then 1, negative 1, 1, 0. Let me know if somebody gets it.
I got negative 0.25, 0.25, and 5.
In 5? Really?
0.5.
0.5. Okay, no, just Oh, shit, I shouldn't erase that. Oh, well. Too late. Can I get someone else to verify? Yes? You said 0.25?
Yeah, negative 0.25.
Negative 0.25.
And then 0.25.
0.25.
Yes, and then 0.5.
0.5. And those, I hope you recognize, yeah? Negative 1/4, 1/4, 1/2. So I'm going back to where I was, okay? I'd stopped to go do partial fraction decomposition. I'm done with it now. So we were at this point, I believe, go back, we were at like 1/2 x squared plus x, right? Isn't that where we were?
1/2 x squared plus x plus 4.
Plus the 4 we pulled out, integral, right? And then we did the partial fractions. And now we know what that partial fraction decomposition is. It's this right here, right? It's this. A, though, for us is negative 1/4, so I have negative 1/4 over x plus 1, plus b, what's b? 1/4 over x minus 1. And then c, which is 1/2 over x minus 1 squared dx. Did I tell you this would be fun?
It was fun.
Did I tell you it was? I didn't say it would be fun, right? I didn't say that, did I? Yeah, okay. Can you handle that? It's going to be a natural log, yes?
Yes.
Can you handle that?
Yes.
Natural log? Can you handle that?
Yeah.
Natural log?
No.
That's not a natural log. That's going to be, because we have a 2 there. We did this again last class, right? You see why I did this last class? We're going to spend our time on this stuff, right? We've gotten it to a point where we can do it. So I'm just going to go straight to the answer here. 1/2 x squared plus x plus 4. I better put like a big set of parentheses here or something. That, I'm going to put negative 1/4 natural log absolute value of x plus 1 plus the 1/4 again, natural log of x minus 1. And then, yeah, let me do it a little slower. I'm going to go 1/2 here. So plus 1/2, bring that half out. And then that right there, this is really going to be u to the negative 2. And the antiderivative of that is negative u to the negative 1. So it becomes, just look at last class. This will become 1 over x plus 1, x minus 1 to the first power down here. Plus c. There it is. We only have 15 minutes left. Gosh.
Do we have to distribute the 4?
You don't have to. You can. Yeah, you can. You can leave it out. All right, let's see if we can't do this one pretty quick. At least on this next one, we don't need long division, right? Doesn't look like it, at least. All right, so we don't need long division. There's nothing I know
Pull out an x.
to do that, so I'm going to start factoring the denominator, right? I'm going to start factoring the denominator. That's kind of the first step to trying to get partial fraction decomposition going. After, if you had to do long division, that would be first step. But after that, we're going to factor. So all I can do is pull an x out, right? I get x squared plus 4. Now,
That's an irreducible.
yeah, this is a linear factor. This is irreducible quadratic, right? X squared plus 4 doesn't factor. So I'm pretty much at a point where I'm ready to go to my partial fractions. So I'm doing my partial fraction over here. I got 2x squared minus x. I'm going to get back to the integral in a minute. Okay, I need a over x, right? So that's a distinct linear factor, so I need a over that. And then, because this is irreducible, take care, irreducible quadratic, I need bx plus c on top of x squared. It would be really not, I mean, I couldn't really give you a quiz on this, right? I mean, we'd eat up like 30 minutes doing a quiz. These problems can take a while. All right, so here we are, right? Clear the fractions. I'm not going to show this step, I'm just going to do it. So if I clear the fractions, multiply both sides by this right here, and then do it over there, I'm going to get a times x squared plus 4 plus bx plus c times x. Right? When I do this over here, they cancel. When I do this over here and distribute, the x kills off the first term. On the second term, the x squared plus 4 kills off, but I still have the x, and it has to multiply by both terms. I'm not even going to mess with this. I'm going to go long way, because this is pretty easy to clean up, right? This is ax squared plus 4a plus bx squared plus cx. Y'all are looking at this weird. Are y'all all right? Did I go too quick there or what? Where did the c come from? This is an irreducible quadratic, right? Anytime we have an irreducible quadratic, we put a linear expression on top, bx plus c. So that's part of the format of the way we always do it. That has to match this side. I'm going to collect my x squared terms together. A plus b,
Is equal to 2.
and then x squared. Yep. And then plus cx, right? And then plus 4a. This system's actually going to be pretty straightforward, I think. Right? Because a plus b has to be what? 2. C has to be -1, match that. And then 4a has to be 4. So wait a minute, I already know what a and c are, don't I?
Yeah.
I don't need my calculator for this. C is -1, I've got that. This tells me a is 1. And if I know what a is, then this is 1 plus b equals 2, right? A is 1. And that means that b is 1. Right? So this becomes integral, and I'm using this piece right here, replacing a, b, and c with what we just got, right? So a is 1, so 1 over x, and then plus b, which is 1, so x, c, which is -1, over x squared plus 4 dx. Yeah? Can you do that one?
Yes.
Yes, right? Yes, Ash.
Where did you get the x minus 1 for the
Here?
dx? Yeah.
Okay, so b was 1, right? So I replace that b with 1, and then c was -1. I get -1 there. Good?
Yes.
I know I'm working fast because I've got 9 minutes. Yeah, so here, let me do this. This is natural log absolute value of x, right? That's the first one. Plus, this might help you. That on that next integral, yeah, let me do -1. If I take this last one, I split it into 2. This first one is a basic u sub. Basic u sub. Let u be the denominator, right? Do you see, if u is x squared plus 4, what's the derivative of that? 2x, you're off by a constant. That's the first type of integration we learned. This is straightforward. This one?
It's triggered that's like tangent.
The tangent, right? This is arctangent. This is the first formula we did last class. So that formula, a squared plus u squared on the bottom, that's this. So I'm just going to finish this up. This is I'm going to put the answer up here. The answer here is natural log absolute value of x plus, here I'll have to scale. So I'll have 1/2 natural log of x squared plus 4. That's me doing a basic u sub, and I'm not showing the work. And this one is minus, here a is 2, so I get 1/2 arctangent of x over 2 plus c. Again, last class, 3 weeks ago, right? And all right, I want to show you, and we're not going to have enough time, I want to show you the last problem I wanted to do today, which was, let's make this this will be a take-home quiz, all right, to be turned in next time. It's not hard or anything, all right? It's just that I'm not going to have time to do it, all right? So I want you to turn this in next time. 3x cubed minus 6x squared minus 11x minus 14 all over x plus 3 squared times x squared plus 4 dx. Oh, wait a minute. Hold on. Shit. I don't remember one. No, that's not it. I had changed it. I forgot I had changed it. Hold on. Sorry, that could have been a disaster. Let me just make sure. Yeah, make this one x squared minus 6x plus 2. I'm going to help you get this started, okay? I'm going to help you get it started, but I want it to be turned in next time, all right? It's going to not be hard, but it's going to be long. This problem's going to take you a while, all right? We've done some of the groundwork for this already. Do I need to do long division? Do I?
Well, the degree on the top is
Degree on the top is 3. What's degree on the bottom? 4, because you would square that, that'd be quadratic, right? And that's already quadratic. So that'd be a 4th degree on the bottom. So there's no long division necessary. All right, so then you factor the denominator. All right, well, it is factored, right? This is a repeated linear factor. This is an irreducible quadratic, right? You're not factoring this. So what is it if I do partial fractions over here? I'm going to have 3x cubed minus 6x squared minus 11x minus 14 over this x plus 3 squared, x squared minus 6x plus 2 equals, what do I need for the x plus 3 squared? A over x plus 3. What else? B over x plus 3 squared plus, now this is an irreducible quadratic, so linear on top, cx plus d over x squared minus 6x plus 2. All right, now you have the pleasure of clearing fractions, all right? And when you clear the fractions, after you do that, you're going to have to get all your system set up. The system you set up is that problem I asked you to do on your calculator. Remember I asked you to put in, I think it was a plus c is 3, negative 3a plus b plus 6c plus d is negative 6. Remember that one? We got those answers? Do you remember what answers we got?
2, negative 4.
You got it there? Okay, so you are going to find out, okay, but I want to see all this work. Like I want to see you do this, all right? So what are you going to find out? That a is what? A is 2. You're going to find out that that's a 2, okay? You're going to find out that b is a what?
Negative 4.
Negative 4. C is going to be 1, and d is going to be negative 2. So this will turn out to be x minus 2, right? That's what you're going to wind up with. Easy, easy, not so easy. It was easy over here because I could split it into 2. Remember I took this and I split it into 2? One of them was basic U sub, the other one was the formula for arctan. The reason I could split it is because it was x squared plus 4. Here, you don't have that. So go back in your notes from last class and look at how you deal with a linear over an irreducible quadratic. This was that special method I showed you where you have to make the top become the derivative of the bottom. Y'all chose that way, right? Remember I'd shown that to you? I was like, do you want to see the way I do it, or do you want to see the way the book does it?
So you do U sub first.
So you say, okay, I want the top to be what?
2x minus 6.
2x minus 6. And it's x minus 2. So you make it 2x minus 6, break it up, complete the square. When's our next test? The 12th, I believe. 12th of October. Wednesday, October 12th. We are officially done with the techniques of integration. This is the last technique right here. So we've learned basic U sub, we've learned integration by parts, we've learned trig integrals, trigonometric substitution, partial fraction decomposition. Those are the techniques of integration. So now what we're going to do, starting next week, is we're going to start talking about what does the antiderivative allow us to do, right? Like, why is it useful to be able to find the antiderivative? We'll talk about the definite integrals, then we go right into improper integrals, and then after that we have our exam, and then we start getting into the real applications, areas, volumes, a bunch of other things like that. All right, have a good weekend. Do your homework for this section. I think it's only the odd problems are assigned. Hello?